Okay, so this is about so yesterday we have seen, we have started the unit 5. In that we have the topic of the double integrals. So in the double integrals, one example problem we have done how to do the double integration of the given any function. So that with that example, whatever the procedure is done, same you will have for the even polar coordinates. Okay. So in this, if you will see, this is the second topic in this double integrals in polar coordinates. So you can find even the problem with the help of converting the here whatever the function was there that into the polar coordinates. Okay, sometimes you may not do easily with the help of the double integration. So you can convert it into polar coordinates and then you can do the solution. And another topic is change of order of integration also is there. So these problems you'll get for the 10 marks question. And here, so for the conversion, you have to do first r square equals to x square plus y square. And also next dx into dy is equals to r into dr into d theta. Okay, these substitutions if you'll do in the given problem, then it will be converted into the polar coordinates. So polar coordinates are what? R and theta. So when you convert them into polar coordinates, even the limit values also will change. Okay. So in the given problem, the limit was from x, y equals to 0 to a and x equals to 0 to under root of a square minus y square. Okay. So these two, we will convert them with the help of the conversions here. So here r is equals to 0 to a, you will get, and another one is theta is from 0 to pi by 2. So r, this one you can do with the help of, that is from 0 to root of a square minus y square is there, no? In that, if you do the squaring on both sides, and then you will get it as a square equation, that is x square plus y square equals to a square. So with the help of this diagram, you can take the limit values of theta. Okay. So theta is from 0 to x equals to 0 to a and y equals to 0 to a. So both the values you are getting same. So like this, whatever the quadrant you are taking from here to here, the value will be there. Okay. From here to here. So it is in the first quadrant, positive a and positive a. And it will be negative and negative. You are not having the negative values in the given one. So only this quadrant you are taking. So the theta will be from here 0 to, this is pi by 2, no? So that's why 0 to pi by 2. And next, these r values, when you substitute in that, you will get it as r equals to 0 to a. Okay. So here you are substituting x square plus y square as r square and dx and dy as this value. So you will get r cube. So r cube into dr into d theta. So r cube, if you do the integration, r to the power of 4 by 4. And when you substitute the limit values in place of r, you are substituting a. So a to the power of 4 by 4 into d theta. So a to the power of 4 by 4, you take outside. And you do only the integration of d theta. So d theta means here constant term is there. So constant integration is whatever the variable is there, that variable you will get. So it is theta. So 0 to pi by 2. These are the limit values. So first you substitute pi by 2. If you substitute the theta value as 0, you will get that value as 0. So a to the power of 4 by 4 into pi by 2. So it is equals to pi by 8 into a to the power of 4. Okay. This such type of problems you will get for the 10 marks of questions also. So one more topic is about the change of order of integration that you can see from the textbook. Next, we are going to the 6th unit. 6th unit is about the multiple, there is a triple integrals is there. So here we have seen 2 integrals now. One more integral will be there, that is called as a triple integral, and applications of multiple integrals. So where we apply these, so that applications are there in this one. So here you have only x and y as a limit values. So in triple integrals, you will have one more limit value, that is z will be there. So f of x comma y comma z be a single valued function of independent variables x comma y comma z in finite region V. So then how you will find the integration of, that is triple integrals, that is f of x comma y comma z into dv. For the triple integral, we represent it as dv, and dv is equals to dx, dy, dz. Okay. So how to evaluate the triple integral? Some rules are there. So that rules are, first z limits, we have to do the integration, then y limits, then x limits. Okay. So like that, first you have to do z values, then you have to do y value, then you have to do the x last one. So at a time you can't do all the three, no. So two terms you have to keep constant, and one term you have to do the integration, and next time another next term you have to keep constant, another whatever the term is left you have to do the integration. Last, after substituting the limits, only one term will be left, that is with respect of dx you have to do the integration. Okay, it is about the triple integrals. Triple integrals will be like this. V f of x comma y comma z is equals to into dv. Okay. So like this we represent. Here whatever dv is there, that will be dx, dy and dz. Okay. So an evaluation of triple integrals is how we'll evaluate the triple integrals. So the given problem will be like this: x1 to x2 limit. These are the limits here. This is y1 to y2, and next is z1 to z2. F of x comma y comma z into dx, dy, dz. Okay, given problem will be like this. So first one, first z is integrated, then y, and last x is integrated. Okay, first z should be integrated, then y, then x. Okay, and last x is integrated. So first thing is, and the limit values, how you will have the limit values means z limits are here, that is you can take integration of x1 to x2, next to y1 to y2, integration of z1 to z2, f of x comma y comma z, dz into d by dx. Okay, like this you have to do. Same as the double integral only. Okay, and the limit values will be either constants or function of x and y. So here z limits will be, so how to identify, means sometimes they will not mention that x equals to 0 to a, or y equals to 0 to b, or z equals to 0 to c, like that. So how to identify these are the limits of z and y and x means z limits are either constants or functions of x and y. Okay, and next y limits are, so either constants or functions of only x. Okay. And last one, x limits are constants. Okay. So x limits will be constants. Like this, we have to identify in the given problem which are the limits of x and y and z. Okay. So this is the procedure how to evaluate the triple integral. So now we'll see one example problem regarding of this one. So evaluate so in this it is mentioned the limits x equals to 0 to 1, y equals to 0 to 2, z equals to 1 to 2, x square yz dx dy dz. Okay, like this. X square yz into dx into dy into dz. So how to solve this means first you have to do the integration of z. Okay. So here y and so x square is there, no? Anything, anyway, if you do, you will get the same procedure only. You will see with the help of this one. So x square y, you are taking outside, then integration of z equals to 1 to 2, z into dz into dy into dx. Okay. So then x equals to 0 to 1, y is equals to 0 to 2, x square y. So z means it is z square the limits are 1 to 2 dy by dx. So it is x equals to 0 to 1, y is equals to 0 to 2, x square y. So if we substitute 2 square means 4, 4 by 2 means 2 here. Minus 1 is there. So 1 by 2, minus 1 by 2 into dy by dx. Okay. So it is equals to x equals to 0 to 1, y is equals to 0 to 2, x square y, and 2 to the 4, 4 minus 1 means it is 3 by 2. 3 by 2 into dy by dx. Okay. 3 by 2 you take outside. Now integration of x equals to 0 to 1 and x square you take outside. Then y equals to 0 to 2, y into dy into dx. Okay. So now it is equals to 3 by 2. Integration of x equals to 0 to 1, x square, y is y square by 2. So 0 to 2 into dx. So when you substitute 2 means it is 2 square is 4, 4 by 2 means 2. And when you substitute y value as 0, you will get it as 0 only. So this is only 2. So that is 3 by 2 into 2. Integration of x equals to 0 to 1 into x square into dx. Both 2 will get cancelled. So here what we got 3 into integration of x equals to 0 to 1 x square into dx. So it is 3 into x square is x cube by 3 into 0 to 1. Okay. So it is, if you substitute 1, what you get 3 into 1 by 3. This is 1 by 3. If you substitute 1, And if you substitute 0, it will become 0. So only 3 into 1 by 3. So 3, if you let's cancel, it is 1. Okay. So the answer is 1 for the integration of x square yz with the help of the 3 integrals. Okay. So this is the way how you have to do the integration of the given problem. So how you will have the limit values also you can see and you can identify them and you can write the problem. So one example problem I have told you. So see the example problems from the textbook. So exercise problems are there, example problems are there, and even MEQ questions also will be there. No? So that also you'll have in the textbook. So try to practice them. So other than this, if you have the limits like this, that is only, it is not mentioned that whether they are the limits of the x or y or z. Okay. So if you have the problem like this, second one. So 0 to 1 y to 1. Okay, y is from y to 1. And next z is from 0 to 1 minus x into x into dz, dx, dy. Okay. So now first we will do the z now with respect to of z. So this is 0 to 1, this is y to 1. Now we take x outside and dz here. It is 1 into dz. Integration we have to take. That is integration of 0 to 1 minus x, 1 into dz into dx into dy. Okay. So integration from 0 to 1, y to 1, x into integration of constant is, that is whatever variable will be there. So z into 0 to 1 minus x, dx, dy. Okay, here 0 to 1, y to 1, x into, now substitute the limit values. In place of z, 1 minus x. So x into 1 minus x. Next in place of z, 0. So it will be 0 only. Next dx into dy. So first to simplify this one. So 0 to 1 and this is from y to 1. X into 1 is x. X minus, that is x into x is x square. So x minus x square into dx into dy. Okay. X square into dx into dy. So next we'll do the dx one. So what is the dx values? Dx values is from, that is the limit value is from y to 1. Okay. So it is equals to 0 to 1 integration of y to 1 x minus x square into dx into dy. So it is equals to integration from 0 to 1. So integration of this one. So integration of x is x square by 2 minus x square is x cube by 3 y to 1. Okay. So x limits are from y to 1 into dy. So how to identify the limits means just before starting we have seen no evaluation of triple integrals. So in that z limits, here it is not mentioned whether it is x, y or z. Okay. So by identifying with the help of these points, that z limits are either constant or they have the function of x or y. Okay. So here x is there. Here it is a constant is there. Here it is x is there. So it is of z. And next, y limits are either constants or functions of x. Okay. So y limits will be here y. If you'll see here y is there. So if you think that this is the limit of the y, then according to this condition, it is wrong. It should have the limit of x, not the y. So here it may be constant. So here constant is there. That's why you can take this as for y, this as for z, and remaining one is for x. Okay. So x1 and x2 are either the constants or the functions of y will be there. Okay. So from y to 1, first substitute the upper limit, that is 1. So 0 to 1. So when you substitute here 1 value, 1 by 2. Next 1 by 3. Next minus of lower limit, no? Lower limit is y. So here y square by 2. And minus of minus. Plus it is, so y cube by 3. Okay, into dy. So it is equals to integration of 0 to 1. 3 2s are, it is 6. If you see the LCM, 3 minus 2. So 1 by 6 you will have, minus this also if you take the LCM, it is 6 you will get, and 2y square minus 3y square plus 2y cube you will get. RS keep like that only. So why? Because we need to, again we have to do the integration. So minus y square by 2 plus y cube by 3 into dy. Now if you do the integration with respect to of y, so it is 1 by 6 into y. Why? Because this is a constant term, no? Y minus this y square will become y cube. So y cube by 3, no? 3 2s are, it is 6. Next plus by 4 it will become y to the power of 4 by 4 into 3 is 12. So 0 to 1. Okay. So these are the limit values of this one. Now you have to substitute the upper limit and lower limit. So if you substitute here y value as 1, you will get it as 1 by 6 minus 1 by 6. Okay. In place of y, 1. So 1 by 6. Next 1 by 12. So plus and minus both will get cancelled. It is 1 by 12. Okay. So the answer is 1 by 12. Like this, if we have, it is not mentioned in the limits whether they are limit of x, y or z. With the help of that, no, we have seen the remarks, no? So with the help of that, you identify which are the limits of which one. Why? Because if you do not identify as the correct, so then you will not get the correct answer of that one. Okay. So this is about the unit 6 triple integrals. So next we have the third unit. So third unit, you see it is a vector integration is there. In that you have the topics of the line integral and also surface integral and also volume integral. Okay. And you have the definitions of what is line integral, what is surface integral, and what is a volume integral. And last one is about the curvilinear coordinates are there. So on this also you will have the problems on line integrals. So how the line integration notation will be there. So it is the integration of f dot dr. And if you have the surface integral, just I will tell how it is representing, whether it is a line integral or surface integral and also volume integral. So see the problems from the textbook. line integral definition you have in the textbook. So see from that. Sometimes they will ask line, surface, and volume integral definitions also. So block 3. So unit is unit 7 it is. So line integral means, so see the definition. So line integral, you will represent it as integration of C f dot dr is equals to integration of f1 dx plus f2 dy plus f3 dz. Okay, like this we'll do the integration of line integrals. So in this also you have many notes are there and remarks are there. You can see from that. And surface integral is surface integral will be like this integration, double integration of surface S f dot n. N is here unit vector. ds is called flux of f over s. Okay. So surface integral means we'll represent it as a f dot n ds. So evaluation of surface integral, you have some representations are there in your textbook. So main this f dot n ds is called as a flux. This is even called as flux of f over s. Okay. So in evaluation of this, so evaluation of surface integral, so you have the formula. This is integration of f dot n ds is equals to integration of that is region R dz by dn I cap here. So I cap is unit vector along x-axis. And similarly, it is equals to integration of R f dot n. So here dy by dz, no? So dx will dy. Dx dy by that is n dot r cap. R cap is a unit vector along z-axis. And it is equals to same R f dot n. In place of ds, we are substituting it as dz dx. And n dot j cap. Okay, j cap is along y-axis. Okay, so like this it will have, it is along x-axis, it is along z-axis, it is along y-axis. So you have to find these problems with the help of this formula for the surface integral, for the line integral, this one. So this, if you learn the third block concept, you can do the problems on fourth, that is the fourth unit is, fourth block is there. In that you have the theorems are there. So 10, 11, 12, 3 theorems and its applications are there. Okay. So volume integrals means, next this is the line, next one is the surface integral. Next, if you see the volume integral. So volume integral will be represented as 3 will be there, f into dv. Okay. F dv, this is called as a volume integral. And how you will find the volume integral means, and its application also will be there. So these, if you know how we'll represent line integral, surface integral, and also volume integral, with the help of this only, we'll do the theorems. In fourth block, you have the Green's theorem is there, and next you have the Stokes theorem, and next one is a Gauss divergence theorem. So Gauss divergence theorem you will do with the help of the volume integral. Okay, and Stokes theorem will be of the that is a line integral you will have. So their representation, last question, 12th question will be there no in the question paper. It will be asked from the block 4 and any theorem regarding of these theorems. One theorem you will get as a state and prove the either Green's theorem or Stokes theorem or Gauss divergence theorem. So, and it will be 10 marks question. You will get it. Proof they will ask you, and you have to write the statement of that one. And sometimes application also will be there. Means with the help of the Green's theorem or by using the Green's theorem, you have to solve the problem. Okay. So just we'll see in the block 4 how Green's theorem, Stokes theorem, and also Gauss divergence theorem are represented. So proof you see from the textbook. Block 4. So unit 10, 11, and 12. Okay. So units 10, 11, 12. In 10th unit, you have Green's theorem is there. So Green's theorem. So statement will be there, that is, let A be a closed region in XY plane bounded by a simple closed curve C. Let M of x comma y and n of x comma y be continuous functions having continuous partial derivatives in R. R means here region will be there. So then, so representation of like this. C M dx plus n dy. Okay. So this is equals to double integration of R dou n by dou x minus dou m by dou y into dx dy. Okay. Where C is transversed in positive direction or anti-clockwise. Okay. C is the curve. It is closed curve will be there. With the help of the positive direction, you can take this one. And representation of the Green's theorem is that m into dx. M is here. M is of x comma y and n is also a function of x and y. So m dx plus n dy, it is equals to double integration of dou n by dou x minus dou m by dou y into dx into dy. So proof, you have to show that right hand side is equals to left hand side. So you will have the diagram also. With the help of the diagram, you have to show that this value and this value both are same. Then it completes the Green's theorem proof. Okay. Next we have Stokes theorem is there, and application means by using this theorem, you have to solve the problems. Next one is Stokes theorem. Okay. Next Stokes theorem, how you will represent means, let vector f be any continuously differentiable vector point function in a region containing a surface S bounded by a simple closed curve C. Then, so for each and every theorem compulsory, you will have the diagrams. So in the examination, you have to draw the diagrams also, and you have to write the statement and also proof. Okay. So then only you'll get the full marks for these theorems. So Green's theorem is somewhat small one compared to Stokes and divergence theorem. Okay. So practice all these theorems and also try to compulsory draw the diagrams. Okay. Don't forget to draw them. So let F be any continuously differentiable vector point function in a region containing a surface S bounded by a simple closed curve C. Okay. So then integration of that is C f dot dr. We have seen the line integral now. Dr is equals to double integration of S curl f dot n ds. Okay. Where n is unit vector unit normal vector at any point S. At point S. Okay. So like this, if you write the statement, we will get 2 marks for the statement and 8 marks will be for the proof. Okay. So line, your Stokes theorems, whatever is there, this is the line integral and this is the surface integral. Just now in the third block you have seen, no? So how line integral is defined and also how surface integral is defined. So this is integration of f dot dr is equals to integration, double integration of curl f dot n ds. Okay. So this, whatever Stokes theorem is there, it gives the relation between surface and line integrals. You can remember this one, and even you may get in the objective type of question, that is which theorem will give the relation between the line integral and also surface integral. Okay. So this Stokes theorem gives, why? Because this is the line integral and this is the surface integral. So next, last one is the Gauss divergence theorem, that is you have in unit 12. So Gauss divergence theorem, it will be for the volume integral. Okay. So we have seen volume integral now, that you will have for the Gauss divergence theorem. Next, last in the 12th unit, you have Gauss divergence theorem. So Gauss divergence theorem. So it, whatever the Gauss divergence theorem is there, it reduces a surface integral to the volume integral. Okay. So Stokes theorem, it gives a relation between the line integral and the surface integral. But here Gauss divergence theorem, it reduces, means it converts the surface integral to the volume integral. So that is the main concept of the Gauss divergence theorem. And the theorem is, if V is volume bounded by a closed surface S, and F is a vector point function. Vector point function with continuous derivatives. With continuous derivatives in V. Then, so surface integral to volume integral. So surface integral representation is S f dot n ds is equals to volume integral means triple integral V div V, that is div f into ds. Sorry, dv. What is dv? dv is dx, dy, dz. Okay. Where n is the, so n is the outward drawn unit normal, outward drawn unit normal to S. So these all, whatever the terms are there, V and S and F, And these you can represent in the diagram. In the diagram, you will have these all points will be there. So like this, you have to write the statement and you have to do the proof of the theorem. Okay. So Gauss divergence theorem means here V is the volume bounded by a closed surfaces and F is a vector point function with continuous derivatives in that. So then this is the surface integral and this is the volume integral. So the surface integral is reduced to volume integral. So there Stokes theorem, you have the relation between line integral and also surface integral. Here conversion will be there from here to here. And proof means right hand side should be equal to the left hand side. So like that, see the proof here for the Stokes theorem and also for Gauss divergence theorem, Cartesian form will be there. So one will be converted to another form, then you will do the procedure. Okay. That Cartesian form also you have to write and you have to draw the diagram and then you have to do the proof of that one. Okay. So these are the third and fourth block. Just have given the introduction of the topics, whatever you have in there. So with the help of this, you do the problems and practice all the questions and practice the problems which I have told regarding of them. See the problems from the textbook. Okay, this is about the vector calculus. So elective B.